Hello and welcome back to our foldable. Um, we have already started working on our operations with integers. We reviewed a little bit as well. So today, don't forget to pull out your foldable. I have one that has been started. This one right here, which we started with yesterday. Just a quick little rundown. We have operations with integers. Again, right at the moment, you are not using a calculator. Eventually, you will be given a calculator based on certain standards that you are allowed to use them. Basic integer rules, though, you have to be ready for anything. So you're adding rules from yesterday. We had to use two different sides right here. So if we have our same signs, we have negative and negative. And of course, a positive plus a positive is still going to be a positive. So that does not change. So your step one right here, you have find the sum, which means you are going to be adding them. And you're going to be adding them to get the answer of the absolute values. So we have talked about absolute value. The outcome is always positive unless the sign is on the outside. So in this case, we are taking the absolute value of 13, negative 13, and the absolute value of negative 6. We're putting them together to equal 19. We're going to keep the original sign, which is negative 19. And again, we went over this yesterday, which is why I just reviewed it pretty quickly. All right, different signs. That means that you have one negative, one positive, and it could be flip-flopped as well. You could have a positive and a negative. So again, you are going to use the absolute values, only this time you're going to find the difference of the absolute values. So you're going to take 13 and 6 and you're going to subtract them and you're going to get the answer of 7 and keep the sign with the larger absolute value. So when you go back up here, which one's bigger? That would be 13. And going back to the original, it is a negative, which is why there's a negative 7 for that choice. Okay, so negative 13 plus 6 is equal to negative 7. All right, so our adding rules. Moving on from our adding rules, we're going to go on to our subtracting rules. Now, the good part with subtracting, we have kind of already learned what we needed to do. Adjust my camera a little bit for you. Sorry. All right, so our subtracting rules, we're going to go ahead and flip it up. We don't need that much space this time, so we're going to just go ahead and use this space right here. So our subtracting integers, I use a method some of you are probably familiar with, and honestly, again, this is just a strategy. So if you see one that you prefer, by all means. So if you have negative 7 minus negative 5, the strategy that you could use is keep, change, flip, keep, flip, change, however you want to incorporate it. I kind of use a strategy KISS because of, well, one, it's silly, and most of the time you remember silliness. So you have keep it, switch, switch. So what I mean by that is your first number, you're going to keep it the same. So that is going to stay negative 7. Your second, right here, your S, you are going to switch. What I mean by that is you are going to switch the minus to a plus. Then you're going to switch again, which is the S's mean the same thing. So we're going to switch, only this time we're going to switch the negative 5 to a positive 5. So now we have an expression of negative 7 plus 5. Well, you should recognize that we now have addition. So go back to the addition rules. Which means you're going to look at this as your new problem. You're going to go back up here, and these signs are different. So we're going to follow the rules of different signs. So it told us to find the difference of absolute value. And then we keep the sign of the larger absolute value. So if we follow these rules, we're going to subtract their absolute values. So negative 7, the absolute value of negative 7 is 7. We're going to subtract the absolute value of 5, which is 5. 7 minus 5 is 2. And again, going back up here, which value has the larger absolute value? And according to that, it should be this negative. So your answer will be -2. And the reason I was telling you that, it's kind of a silly thing, but with the KISS method, so this is where the silliness comes in. If you see this minus sign, it hasn't been kissed, so it should be kissed. If you have seen the plus sign, like you did on the first situations, they have already been kissed, so you don't want to keep it switch. That's where the silliness comes in. Already been kissed, hasn't been kissed. And please listen to this video in its entirety so I don't walk around with people just kissing, because that's not what I'm talking about. All right. All right, last one. I know that this last part is pretty simple for most of you because they go together. So our last situation is we are going to talk about multiplying and dividing. So you only have to remember the rules the exact same. All right. Now, some of you like the Dorito. Some of you like the tic-tac-toe. All right. I'm going to explain a little bit of all of that. Again, if you have multiplication or division, all these scenarios will work with both of them. The only difference is you have to remember the actual answers. Okay. So this -5 times -4, my signs are the same. Same signs. And I'm using words because vocabulary is important. The product or quotient will be a positive integer. Or I should say, let me say this again. It's going to be a positive solution. Let's start using different vocabulary words. There we go. All right. So with that being said, 5 times 4 is 20. They're both negative, so I'm going to make them a positive. So same signs, your outcome will be a positive outcome. And again, product or quotient. And then you have a second example. -20 divided by 4. Yes, it looks like a fraction because that is exactly what a fraction is. It's a division problem. -20 divided by 4 is 5, because 20 divided by 4 is 5. And it doesn't matter, it will be negative. So if I reversed the negative and put it on the bottom, it again will still be a negative outcome. So I'm going to sum this up for you. Different signs, the product or quotient will be a negative solution. Okay. Now, a lot of you have talked to me about the Dorito, the tic-tac-toe. So this is where those come into play. So the Dorito looks like a triangle. You have a positive and 2 negatives. Doesn't matter where you put them, by the way. So if I take this information and I say, okay, -5 times -4 equals +20. Good morning, Wildcat. Just a quick announcement. Gotta love those little announcements, right? Okay, so +5 times a -4 will equal a -20. A -5 times a +4 will equal a -20. It doesn't matter where you start, which direction. It's really pretty nice. Same thing with division. You take the number, divide it, and it gives you the outcome of the other one. Now, the tic-tac-toe, little more organization needed. All right, let me make sure that I get all my positives and negatives right. So all of your positives will go in a diagonal format. and then all of your negatives will go in the rest. So when you have a negative times a positive, sorry, I said that backwards. When you have a positive times a negative, that will equal a negative. When you have a negative times a positive, that will equal a negative. A negative times a negative is a positive. A positive divided by a negative equals a negative. A negative divided by a negative is a positive. So you can go in any order, any type of tic-tac-toe format. That's why they call it the tic-tac-toe way, because you have to go in the same direction of any actual tic-tac-toe winning. Okay, so lots of strategies. We will talk about the reasons behind it all, but this video is definitely way too long, and I need to make sure that you stay focused. When you are done with your foldable, I want you to find a teacher, calmly, of course, or get your yellow clothespin and let me know that you need someone to check and sign your exciting playlist. All right. And I think that's it for right now. Thanks for bearing with me. Remember, you can always go back and rewind. All right. Awesome. Thank you.